Hello, viewers. This is Dr. Mercy Anthony, Head Department of Statistics from St. Joseph's College of Arts and Science, Cuddalore. I hope you will find this video informative, and by the end of this video, you will be able to understand students' T distribution and the problems relating to students' T distribution and the solution how to solve the problem. The students' T deals with the problems associated with inference based on small sample. So now what is small sample means? When the n value is less than equal to 30, that is small sample. So in small sample, we'll be using students' t-test. So now students' t-test is one of the most commonly used techniques for testing a hypothesis on the basis of a difference between sample means. Explained in layman's term, the t-test determines a probability that the two populations are the same with respect to the variable tested. The criteria for t-test is if there is a direct relationship between specific data points from two data sets, such as measurements on the same subject before and after, then the paired t-test may be appropriate. The number of points in each data set must be the same, and they must be organized in pairs in which there is a definite relationship between each pairs of data points. These are the few points where t-test will be applicable. So now here we'll see some of the examples for applying t-test. So the paired t-test is generally used when measurements are taken from the same subject before and after some manipulation such as injection of a drug. So the first example is we can use a paired t-test to determine the significance of a difference in blood pressure before and after administration of an experimental pressure substance. You can also use a paired t-test to compare samples that are subjected to different conditions, provided the samples in each pair are identical otherwise. The second example goes like this. We might test the effectiveness of a water additive in reducing bacterial numbers by sampling water from different sources and comparing bacterial counts in the treated versus untreated water sample. Each different water source would give a different pair of data points. So the basic concept is, suppose any test, if we are going for any test, what we do is, first if we are taking the sample before test and after test, in that case we'll be applying paired t-test. So it will be more clear by this problem. So the paired t-test can also be known as test for difference of population mean. And here the population mean, the testing is on dependent sample because the same values we are going to conduct before and after. So the value will be dependent sample. So the problem goes like this. The marks obtained by 10 students before and after coaching are given below. So before coaching values are 84, 48, 36, 37, 54, 69, 83, 96, 90 and 65. The after coaching values are 90, 58, 56, 49, 62, 81, 84, 86, 84 and 75. So the problem here is, what we have to test is the coaching effective? So the first step goes like this. We have to set up the null hypothesis. So the null hypothesis here will be the coaching is not effective. That is, H0 says that mu1 is equal to mu2, where mu1 denotes for before coaching and mu2 is for after coaching. So the alternative hypothesis will be the coaching is effective. So that is H1 says that mu1 is less than mu2. So once the criteria comes like less than or greater than, so it becomes the problem of one tail problem. So next step will be test statistics. Under null hypothesis, the formula goes like this. Modulus of t is equal to d bar divided by s by root of n minus 1, which follows t of n minus 1 degrees of freedom. So here, where d bar is equal to summation d by n, that is the formula, and s is equal to root of summation d square by n minus summation d by n the whole square. So now what we have to do is we have to frame one table. So the first column will be, or row will be x, next will be y, next is d and d square. So in x and y, what we have to do is we have to write all the values given in the problem, like after coaching and before coaching, the same values will be written in x and y. So the third column will be d value, small d. So which will be calculated by using x minus y. So what we have to do is you have to subtract the values, x value from y value. So the first value here, it is minus 6, minus 10, minus 20 and so on. And next what we have to do is we have to find out the d square value. So you have to square up the d value. So minus 6 squares gives you the answer 36, minus 10 gives you the answer 100 and minus 20 is 400 and so on. So next what we have to do is we have to find out the total value of d and d square. So total value of d gives you the answer minus 63 and d square gives us the answer 1125. After that, what we have to do is we have to substitute in the formula. So the formula, we have to substitute in the formula for d bar. So d bar is equal to summation d by n. So minus 63 divided by 10 gives you the answer minus 6.3. And next we have to substitute in s formula. So root of d square divided by n minus summation d by n the whole square. If we substitute in s value, we'll get the final answer as 8.5. So d bar answer is minus 6.3 and s is 8.5. And next we have to substitute in modulus t formula. So modulus t is equal to d bar divided by s by root of n minus 1. So minus 3.3 divided by 8.53 divided by square root of 10 minus 1. So which gives us the final answer as 2.215. So next step is we have to find out the table value. The table value can be obtained from t table for n minus 1. So that is 10 minus 1, 9 degrees of freedom at 5% level of significance. Here the table value is 1.833. So now what we have to do is we have to conclude the problem. So the inference goes like this. Since the calculated value 2.215 is greater than the table value 1.833, thus we reject our null hypothesis. So we conclude by saying that the coaching is effective. Next, we'll see the next problem. Here the problem is a drug was administered to 10 patients and the increments in their blood pressure were recorded to be 6, 3, minus 2, 4, 3, 4, 6, 0, 3, 2. Is it reasonable to believe that the drug has some effect on change on blood pressure? So here, in the problem itself, they are asking to find out the blood pressure which is in high value, so increment value. So our null hypothesis goes like this. The drug has no effect on change on blood pressure. That is, H0 says that mu1 is equal to mu2. And the alternative hypothesis is the drug has some effect on change on blood pressure. So that is H1 says that mu1 is less than mu2. So here the problem becomes of one tail. So again what we have to do is like last problem, we have to substitute in the formula. So d bar is equal, modulus of t is equal to d bar divided by s by root of n minus 1 follows t of n minus 1 degrees of freedom. So now here, compared to the previous problem, here x and y values are not given. So directly the d value is given to us. So what we have to do is we have to just square the values, square the d value. So the d value 6, 3, minus 2, 4. And the d square gives you the answer. If we square 6, we'll get the answer as 36. So 3 square is 9, minus 2 is 4, 4 square is 16, minus 3 is 9, and so on. So likewise, we'll find out the total value. So the total value of D is 23 and summation D square is 139. And once if we apply in the formula for D bar, we'll get the answer as 2.3 and S value is 2.9 and T value is 2.35. So this is our 2.35 is our calculated value. So next we'll go for the table value. So the table value can be obtained for n minus 1 is equal to 10 minus 1, 9 degrees of freedom at 5% level of significance. The table value here is 2.26. So what we have to do is we have to conclude the problem. So we'll go for the inference. Since the calculated value 2.35 is greater than the table value 2.26, thus we reject our null hypothesis. That is, the drug has some effect on change on blood pressure. So with this, the problem gets over. I hope you understood the concept. Thank you for your patient listening.